lot of you guys did this like last Wednesday, last Thursday. But I think the title was Properties of Logarithms. Does that kind of ring a bell? Mm-hmm. Hey, look at number 4 and number 6. Weren't they literally just saying what properties? We have the product property, and we have the quotient property. And now just for our minds, remember, we have the single side and we have the separate side. Sometimes, and maybe you don't fully have a context until we get to section 3-4, but it is going to be useful to condense, right? And what's the word for this side? We have condensing coming together to a single, and we have, louder. Expanding, separating. The expanding gets us simpler arguments. The condension gets us a single log. We'll see today in section 3.4. It's a really cool section as far as like, oh, this is practical. Number 14. You guys are just changing the base except. Did anybody get confused on these directions? Nobody? Did they tell you what to change it to, or just change it? Oh, this is awkward. We're so quiet. I know you said to change it. It just said to change it, which was kind of weird because then some of you, hopefully, were like, change it to what? Except. What did we talk about? Anyone remember? In the scientific, mathematical community, in your future studies, whatever direction you go, biology or chemistry or physics or business, what is the most common, which is awkward because I'm using the word common, what's the most common logarithm that's used? Natural log, not the common log. I mean, common log's good. There's a button on your calculator. I'm sure it's used somewhere. But what's the one that you're going to see the most? ln. So if you were just going off of what I said, which is kind of a preparation for, the book is going to lean to ln because all future scientific mathematic endeavors are going to probably have ln somewhere. That would have been a great one to go, but they also use the common log, and you could have done something random, like log base, give me a number, anything, go. 4. Sure. You could have used log base 4 or log base 5. You could have gone any direction with this problem anyway. But where's the book going to lean, and where am I going to lean? Right here. Okay? Number 16. Why not any further? Is 3 a perfect power, 2? No. Okay, you're stuck. You're done. But why do they keep going with this guy? Well, because 4 can be written as 2 squared and log base 2 of 2. Hey, what happens when I have log base a of any a? Exactly. Get rid of as much as you can, right? Same thing with number 20, in that this one, ln of e squared, the 2 comes down, power property, ln of e is just 1. Now, wait a minute. I'm not saying they're wrong. Technically, they're not, according to PEMDAS. But what would be a much, 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 much better way, less confusing way of writing that answer? Got it. Justin, explain. Why?
Because numbers. I'm not good at explaining. Sorry.
It's okay. Do you want to pass it off? Who's going to take it? Dylan.
Yeah. Oh, I didn't.
He was just applauding your effort because numbers. Why? Spencer.
Because like when it says ln of 6 minus 2, it looks like ln of 2.
Yeah. A lot of people would make a common mistake of like, yay, 6 minus 2 is 4. This is awesome. Will the decimals match? No. And remember, decimals can be helpful because the answers are going to appear in different forms, and if they all come back to the same decimal, you're okay. Different decimals, different answers. Well, that's not good. ln of 4 is a no. Why? PEMDAS would say it's ln of what? According to the statement, even though it's written weird, and I like this one way better, it's way less confusing. This isn't wrong. Is it ln times or ln of? ln of. And who is it of? If you're in both parentheses written, it's what's immediately following it. Yeah. What's immediately following it is ln of 6. Can I show you something that calculus kids mess up on a calculus test that has to do with this? You ready? How would you put this? Ooh, nope. Don't worry, it doesn't mess up the illustration. How would you put this into your calculator if you were to put it into your y1 equals? What button would you hit first? I mean, you're in the graph, y equals, got it. You would hit, and when you hit sign, what does the calculator automatically do?
Parentheses.
Okay, you can't change that. We've tried with sine squared, cosine squared weirdness. What would you do next? Would you? Do you know what a lot of kids do? x plus 2, then they end the parentheses. But according to PEMDAS, like this statement too, where must the parentheses be if they are not shown? Just sign of. Are we tracking? Okay. But still, which way is less confusing? I would totally say this is less confusing. So you're going to maybe see some weird reorderings of answers as you go, where you're like, I thought we were supposed to do descending order, something, something, something. But we do tend to put constants in front to make it less confusing when possible. Sorry, here you go, 32, 3/4, 46. Expand it out. Did you go all the way? Number 54. You can see the answer to 32 up there. It goes all the way down to the fullest expansion, being down here. Expanding because going into separate logs, simpler arguments, right? 76, now we got to condense. It's there at the bottom. Let's scroll down in just a second. A few people might be on 46, so. 76, that was a condension, separate logs into a single. Check it. Need more evens or are we done? That's it. Odds, evens, any questions? What do we got? Was it not a bad homework? Give me a thumbs up if you're like, nope, it was good. Give me a thumbs down if it was bad. And the rest of you guys still need to do it. Okay. So, my ones who didn't turn it in, you got it, right? If you get it in by tonight, because I changed the deadline, it's still technically same day credit, 3/4. Get it in by tonight. It won't be half until tomorrow. Sound good? Okay. Last call for questions. Going once, going twice. Sold. Here, let's get back to notes then. Thanks, guys. Get rid of those homework spirals. Notes open. I have this already. Whoa, all these problems are already solved. What's going on? What did we do on Thursday? Yeah, it was the end of notes, but was this section 3.3 or section 3.4? We got done early on Thursday. Early enough that we were able to, well, wait a minute, how did we just start solving problems? I mean, every new section, we learn new stuff, right? We, like, busted out, I think it was even time. You guys were trying to get through all 6 and see if you get all 6 right. Some of you got all 6 or 5 or 4. You were, like, voting and seeing. Because this section is just a culmination, which is kind of cool. Remember how I told you all of chapter 3 is all about the puzzles? Especially in this class, we get super distracted with the puzzles. So that means we enjoy the puzzles, which means maybe we'll have some fun. But can you play? Can you play well? Can you play in a way that you have fun if you don't know the rules? Nope. So, I'm going to come back to these notes in just 1 second, but I know it was like fire day and then it was the weekend. Remember what I challenged you with homeworks? Some of you were popping off and you were able to try all 6 and you got like 3 or 4 or 5, or maybe even all 6. It's kind of exciting. But others of you were like stuck on number 1 or number 2. And I said, oh, it's not going to be fun for you to play unless you actually work with it. You were supposed to finish your 3.3 homework. Remember the foundation, the log properties? And you're supposed to come today ready to play. You have all of 3.1, 3.2, 3.3, exponentially stuff, logarithmic-y stuff, the basics, but also the properties. We're going to have to put it all into play in section 3.4. Because, what kind of equations we're here, guys, solving? Simple. Which means what's coming? Careful with complex. Remember that means imaginary numbers, but complicated ones, right? So hold on. Before I get you back into the notes and what we're writing down, I want you to, okay, this is the book's way of how to solve each and every one. We solved them. I went through all the answers. You saw how many you got right. Some were really good. Some were really bad. Some got to try them all. Some got stuck really early. You're supposed to be developing those skills. This is how the book says you're supposed to solve it. Why were 1 and 2 and 3? I think we skipped one of these along the way because we only had 6 problems, not 7. But 1 and 2 and 3, what property were you supposed to use? And what's the basis of 1-to-1 property? What are we supposed to make them do? Same base, make a match. Exponentials? Yeah, make a match. Logarithms? Yeah, make a match. They have bases too, right? Make it match. Using exponential properties from like Algebra 1. Using logarithmic properties from, well, that was just, I mean, this is algebra. We added it. Make it match, and then it's easy. We can just ignore technically. But what did you need for the rest? What's this property? Well, I'm glad you asked. It's right there. So, quick review. Let me give you a second. They're the two things that we need today. The only two? No. No. We need all the log properties in our arsenal. We need all the basic algebra stuff that we've learned since forever. Addition, subtraction, multiplication, roots. Who knows? But specifically, exponential logarithm. 1-to-1 we don't mind. You can write that little thing that you guys told me and that I've been telling you. Make the bases match. Make the bases match. But it's not always possible. And for some of you, it doesn't really matter that you remember the 1-to-1 property, because you have a way, if you can make them match, you have a way of getting rid of them. Not just ignoring them, but truly canceling them out. I'll give you a second. You're in your notes. We've talked about them. We've done homeworks on them. We've done homework questions on them. We've seen the simple, we've seen the hard. But now it's time to apply it to a much bigger picture. Can I remind you what danger we're trying to avoid? Especially with the inverse properties. What do I not want to see or not want you guys to be thinking? If this were a question on the quiz or on your test. Remember from anything that we've done in chapter 3, as soon as we started talking about logs, what was I warning you of? A kid in Algebra 1 knows to get x. Nikki.
Like it's not distribution, it's
yeah. Number 1, we can't just take log base 7 and say, yay, let's distribute it, because it's not times. And since it's not times, and since we cannot just distribute, there is no property for addition in a single log, only addition of separate logs. We cannot expand addition. We can only condense. Does that mean, if it's not multiplication, does that mean that I can just divide by log 7? No. That's not legal. It makes no sense. We talked about this in class. We went through our calculators, talked about can you just divide by a square root. No, we have to undo it. And guys, the word undo in math, what does it point to? Inverse. Good. Inverse operations. Inverse operations. So what's the inverse of log base 7? We have it right up there. How do we undo a log? What gets rid of a logarithm that's already there? Louder. Yeah, you're right. Louder, Sid. You got it. What do you do to both sides? Put a big, yeah. Raise the side as a power of 7. I know it's weird to know how to say that, right? It's like totally brand new with logs. Wait. But what we do to one side, we have to do to the. Okay, which one is that? Is that the first inverse one or the second inverse one? The first one. Now this one's weird because this one is not showing the entire equation of you doing it to both sides. This one's just showing what happens when you have a to the log base a. In essence, they simplify. I don't like saying cancel because it doesn't go to 0, but they simplify. Or log base a of a, what happens? They simplify, right? Remember, inverses undo. How to undo a log is how to undo an exponential. You guys ready to play? Pause, give everybody a group a high five, because some of us are either falling asleep or we're not tracking. Calculators should not even be turned on, so put them away, or else I'm going to take it away. Notes should be open. Nathaniel, let's play. Go back to your homework spiral. I know you don't take notes, but you are going to do examples. Let's go. Here we go. So, we have a strategy. Maybe some of you are going to want to write this down, but don't write it down right now. I want us to get straight into playing, and then we'll come back to these steps, and you can see whether or not you want to write them down. All right, so strategy. Gotta get you in the right headspace. We're going to try to isolate. Anytime we're trying to get to x, we're trying to get him isolated, but he's always going to be stuck, either in a log or in an exponential equation. Sorry, an exponential expression. So we need to somehow get that log or get that exponential, get him isolated, move away everything else with all of our algebraic skills. And then either we're going to have matching bases, use the one-to-one property, or we're going to be undoing. We'll get back to this in a sec. But let's just go play, and then we'll come back to these steps and see if we need to flush them out at all. So here we go. These ones. Take a second, write them down. Is it too warm? Do you need to open up the door? Is that what's going on? You're cold? You getting sick? Wash your hands, guys. It might be starting to go around. If you have your water, get it out and start sipping on it. Yeah, you gotta pop it this way. Try outside, yeah? Yeah. Both of them down. And I want you guys to talk in your groups really quickly before I send you, because some of you, I know you're already solving. Just stop, write it down, stop. In your groups. Strategy. Make a match or undo. Ready, set, go. 30 seconds, talk. If you're all in agreement, then go. Make a match. Make the bases match. Or undo.
Oh yeah, we can use the one-to-one.
If you're in agreement, go.
Match A, undo B.
Yeah, that sounds good.
Your entire group. Make it match or undo for letter A. What do you think? Because it already matches. So then that's easy. So how are you going to go? Which property? One-to-one or inverse? So one-to-one tells us to do what?
Oh.
What do we write?
I don't know. I think we're going to do that.
What do we do with the E? Do we have to do something or can we just ignore?
No, actually, so see how this is.
Therefore.
So with the one-to-one property, you just equal to each other.
Okay, you guys know
So
it. Why is it
this is equal to this, and then you just solve like that.
Wait, I thought it was did you get the answer?
Yeah.
But isn't like
How many groups said make it match on letter A? Oh wait, it already matched. Oh, that's awkward. Okay. So did I do the one-to-one property? Okay, so now what do we need to remember? Precalc or just algebra? Algebra, because what is it? Kimi, what is that?
An algebra problem.
Yeah, otherwise known as, what do you have?
algebra?
Solving.
Solve. How?
Function.
Right.
Pandas.
Moving?
Yeah.
Moving. A trinomial.
Say it louder, Nathan.
What's it called?
A trinomial.
Say it louder.
Zero in it.
You guys even hear him? He's saying factoring. He's really trying to get it out.
Oh.
Move it all to one side, factor. Some of you were stuck with the algebra, weren't you? Yeah. Get it started that one. All right, guys, what are my factors?
4 and
negative 1.
Are you going straight to the
Yeah, well, that's negative.
-4 and 1, and so you're going straight to the answers. But wasn't it technically x minus 4 and x plus 1? Those were the factors, right? And the zeros are?
Or negative 1.
Okay.
Very good.
Hey, both of these expressions, what category do they fall under? Logarithmic or exponential? Yeah, no logs anywhere, yeah? Yeah. Okay. So letter A, make it match. It already did. Sweet. Oh, we had to remember quadratics. Okay, it's algebra, but some of you still get stuck. No shame. Reach out if you do. Ask. How about letter B, though? Make it match or undo?
Oh.
Okay, you could have thought make it match. If so, you could have broken down 42 to be 2 and 21 and 3 and 7. Uh-oh, is this a power of 2? Okay. So if that doesn't work, Aiden, I see you. Give me 1 sec. Then Nathan, you're saying divide by 3. So 2 to the x is equal to 14. Hey, 14 is not a power of 2 either. I don't think making it match is going to help. Because I cannot rewrite 14 as a perfect power of 2. There's no way to make it match. So if there's no way to make it match, 1-to-1 property isn't even an option, so therefore what do I have to do? Undo. Undo what? 2 to the power of. So if 7 to the power of log base 7 gets rid of a log, what will undo a 2 to the power of x?
Long.
And here's where life gets interesting. Does a log base 2 work? Yes. Because what can I rewrite log base 2 of 2 to the power of x as? Some of you know, haha, there's a property equals x. And you're totally right. Some of you, it would be helpful to think of the power property that brings the x down in front. And log base 2 of 2 is 1. Either way, x is what's left. And what's on the other side?
Log base 2 of 14.
But can I show you a dilemma? The back of the book, which we go to be like, okay, are we doing this right? Are we along the right lines tomorrow? And well, not tomorrow. When's our homework due? Wednesday when we grade our homework, and you're grading evens. That's not what the book's going to have. But I don't get it. It's so basic. Log base 2 cancels. Done. Do you remember which way I told you they lent? Lent? Lean? Lean. That's more proper. This is their answer. What? But that makes no sense. It was a 2 to the power of log base 2. It cancels out. No big deal. We're done. Guess what's true about their decimals? They're the same. But I got this. But they're going to get that. Now, pause. Why are they showing you this? LNs are more natural. Literally. But like in the scientific, mathematical, future, whatever, remember, pre-calculus, everything else math, it's what you're going to see is LN. They're preferred in so many ways. We have John Yoon in the back. He has his AirPods in, but hold on, take them out. How helpful are LNs in calculus? Would you rather see any other log besides an LN? Nope. Good. Thanks, bud. Okay. They're more helpful. They're better. They're easier. I know, but he helped, right? Okay. So here's the dealio. How do you get here? Some of you are like, nah, I don't mind plugging in lots of stuff to my calculator and comparing decimals, but that's gross. That's messy. That's ugh. How could you get to this answer instead of that answer? What do you see? Okay, you could just change the base. But then you have to have that memorized, right? Okay, but could you use the change of base formula? Yes, because change of base formula says I can change a log base 2 to any other log, including an ln, by taking, remember, the argument over the power. It's a formula. It's a memorized thing. It works. But aren't there just a few of you that are like, I just have to remember that formula and do it every single time? Can I show you another way of solving that would land you in the exact same spot? Ready? What was that problem? 3 times 2 to the x equals 40. Okay. Same first step. Love it. Isolate. 14. My mental math is speaking. Okay. Isolate. I got the exponential by itself. I have to do that. Just a few of you are like, hey, isn't that 6? No. PEMDAS tells me what to do first. Multiply or exponent? Exponent. That's stuck. I can't bring this base in. This is 3 to the power of 1. I can't combine unlike bases. I could run over here and get my, which is missing right now. Here it is. My little Algebra 1 exponent rule book that we did this year. You can only combine exponents if their bases match. 3 and 2 do not match. Anyway, sorry, move it over. Algebra 1 mistake, not 6. What did we do right here in the last way of solving? Log base 2 undoes. What if you knew what was coming and you said, I'm not going to use a log base 2 because they're not going to use a log base 2. I'm going to use an ln. Now, is that kind of counterintuitive because the bases don't match? A little bit, right? But wait. So that doesn't truly undo the 2 to the power of, but doesn't that undo the power of? What can I do with that x by the power of that? Right? So how can I rewrite this? This is dumb. We just had a right answer. I know, but log base 2 is not common knowledge or not commonly used in future maths. ln is for lots of different reasons. Let's just say for right now it's more natural, more naturally occurring. So can't I bring down the power? I know it doesn't undo the 2, the base of 2, but it does undo, any logarithm undoes that raised to the power of x. So now what can I do, guys? Isn't that just a constant? And what do we do with multiplication? Now my ones that are like decimals are good enough for me. Okay, can I just give you a peek at the end of the road? You're on a test. None of the A, B, C, D, E have decimals. None of them do. They're all like logs, ln, something. Okay? Right? You're supposed to have solved an equation. What if you get a form like log base 2 of, what was it, 14? Log base 2 of 14, and it doesn't match any of the answer choices? What are you going to have to do? Think about it. Plug every single one into your calculator until the decimals match. You see it? What's that going to waste? Time. So I know it's annoying. It is still a strategy, and it's not an incorrect strategy, which is why. You ready? If you have your book, you can turn to the back, section 3.4 answers, but don't worry, I'm just doing it up here. I'm going to show you what the back of the book looks like for section 3.4, and it's all based on, once again, you're like, what is the point? This one problem, a simple problem too, at the very beginning, sorry, dual page, of this section. Naturally, we would have, because of the inverse property, it's not bad, it's good math, you're not wrong. We would have written log base 2 of 14, but the problem is, the way people understand it in higher maths or sciences would be ln of 14 over ln of 2. Right now, is it possible to get your wires crossed? To have miscommunication, for you to think you're wrong when you're really right, or for them to think you're wrong when you're really right. This is why communication has to happen. Life lesson, we talked about this a little bit last week. You got to make sure your definitions are all in line when you're talking with someone before you start judging their opinion or their statements. Anyway, oof, that's good. Talked to a history teacher about that one, or a politics person. Mr. Hampton. Anyway, where are we going? Section 3.4. Guys, help me out. What kinds of logs do you see in these answers? Do you see what I mean? This was probably a log base 3 of 5, but they wrote it as ln of 5 over ln of 3. You would have to plug it in, your answer, to see if it matches 1.465. Well, that's annoying. And lns. Oh, okay, well, whatever. They did a common log. lns. Hold on. Don't worry. There's a lot more. What else is in there? Let me zoom out. Give me a sec. And zoom back in. What kind of logs? Do you see it? I'm not kidding, am I? What are they going to use? Because it's more common, it's more the language that they speak. LNs. So, can we go back to the example that we just had? Yeah? I just said super basic, super easy, solve for x. Why? Because that's what you're doing. And I know, even algebra kids are like, hey, there's an x, I want to get it alone. And they'd be right. They just wouldn't know all the skills that you guys do as to how to solve for it. But then, in your directions in homework, it's going to say something to the extent or something along the lines of, ready? Let me see if I can get there. Approximate 2, 3 decimal places. Why is it going to say that? Because your form of the answer might not match theirs, and they don't want you to be like, I'm getting them all wrong, I'm getting them all wrong. Would you have been right? With the log base 14, yeah, you would have been. It's just in a different form. So, are we okay with keeping a wary eye and realizing what we get just because it doesn't match? We don't just give up, we don't just say we're a failure or that we messed up. We actually plug in, like they're telling us to. Plug in the decimals and then make it match. But for those of you that are like, that's so much extra work, my ones that are always trying to get ahead in your homework during class, why not just go straight there and not have to deal with the extra work of plugging it into your calculator? Does that make sense? Yeah. If you can go this way, you end at the answer, as opposed to ending something, you have to then plug it in and then match. So decimals, valid approach, not my favorite and not the most efficient. And didn't we talk about how as math or in math we want to be efficient because we're lazy, we want to finish it quickly? Come on. Yeah.
So when you're just technical question, why do you move the x? Why do you make it multiplying it by x?
I have to because here a log base 2 is perfect for undoing, for literally getting rid of the 2 to the power of and leaving x. But ln log base e of 2 doesn't cancel. So the only way to break up this expression and get x alone is to use the power property, remember? And the power property says log base a of b to the c. Sorry, I'm putting in a lot of things. Remember that c can always come down in front. So I'm just using that power property to say I want ln's. It's not always going to work perfectly, but I can still bring the variable or the argument, the power down and divide. Is that cool? Okay, guys, we gotta get to harder problems before we finish today. We have like 2 minutes. Let's get a really good hard problem. Is that okay? How about number? Don't worry, we have all day tomorrow to practice some more. I'm just grabbing one more along these same lines. Here we go. Why use ln's? Why use ln's? Lucas's face right now is like, why is this a harder problem? Ariana, what's wrong? The bases don't match. It's like a 1-to-1 property that's an epic fail. Like if that was a 2, my life's made. Like x equals x plus 1 actually that's bad. That's 0 equals 1. That never works. But long story short, if they matched, okay, we know what to do, but they don't match. Oh, log base 2! It's not going to help here. Oh, log base 3! It's not going to help there. So instead of having this like epic battle between which one's better, log base 2 or log base 3, let's just agree with the rest of the scientific community and say, oh, neither one. What's the best one? Oh, come on. After all today, what's the best one?
2.
Neither. What's the best one? Natural log. Oh, you guys are killing me. I'm going to go to sleep just standing up here. Log base 2. Nah. Log base 3. Nah. You should have asked Miss Peterson. Did you figure out it was ln? Maybe. Natural. What? Use the natural one. So throw ln, both sides. Okay, what happens? Nothing great. I know. Does the 2 cancel out? No.
Yeah.
No, because log base e doesn't cancel out of 2. E and 2 are different, right? Does 3 cancel out? No. But Nikki, come on. What can you do?
You can use the power property.
Power property. He comes down and he comes down, right?
Yeah.
Okay, rewrite it. Show me what it looks like. Rewrite it. I know, it's not gorgeous because it's not simple, but it doesn't mean you can't do it. Maybe there's a reason they use ln's. Maybe because of this stuff. You have 2 different exponential expressions. What are we talking about tomorrow? Because you just realized what just happened? How are we going to X by itself? Okay, there's hard stuff that's coming. But guess where homework starts? The easy stuff. Bye, guys. Start homework tonight. It's on Google Classroom. See you later. Please, try to shake it off. Your next teacher wants you to go down. Figure out this natural. Yeah.